Okay, so talk about the 2 searches and the 3 sorts you're going to be responsible for in AP Computer Science. So searching is searching for a value. Now this is a list of integers. Let's say we're searching for 7. The first search that you'll have to know is called sequential search. It's the easiest one to understand because basically it just checks each value until it gets 7, what we're looking for. Okay, so in this case it'll take 7 times to get to 7. 1, 2, 3, 4, 5, 6, 7, and then it'll finally get it. Okay, the best case for a sequential search is if the value we're looking for is right here. The worst case is if the value is right here. The average case is pretty much half the list. Okay, because sometimes it'll be below that, sometimes above that, but it averages out to be about half the list. That's sequential search. Okay, now there's another search called binary search. Now binary search in general is faster. However, the benefit of sequential search is sequential search does not have to be in order. Binary search does. So if binary search, I'll do the same list, but it's got to be sorted. So it'd be 1, 2, 3, 3, 4, 5, 6, 7, 8, 9. No. So if this list is sorted, then binary search is kind of like the guess your number trick. So if you picked a number from 1 to 100, and I was trying to guess your number, then I would start off and I would say 50, and you would say no, it's not 50, it's less than 50. So that would immediately eliminate the numbers from 50 to 100 for me, and I know it'd have to be between 1 and 49. Then I would guess 25, and you would say no, it's greater than 25. Okay, so then that would eliminate everything from 1 to 25. So then I would know it would be somewhere between 26 and 49. So binary search works like that until you find the value that you're looking for. But every time you guess, if you did not get it, then you cut your list in half. Okay, which is why it's usually faster, or in general, faster than sequential search. But obviously it's got to be sorted. Okay, so the way it works, I'll just do an example here. Our length is 10. We would cut that in half, and which would be 5. Index 5 is here. And you would say, are you 7? I'm still looking for 7. Nope, not 7. I'm bigger than, my number is bigger than this. Okay, so that would eliminate all this. So now we're looking at this list. Okay, basically you take the average of these indices here, index 6, index 9, and not just the 6 and 9, but those are actually the indices. This is the 6th element. Or it's actually the 7th, but it's index 6. This is index 9. Alright, there are 10 numbers, index 9. And you take the average of those and you get 7.5. Well, if you do integers, that's just 7. So index 7, which is the 7th. So on the second check, we found 7 using binary search. So we found our value. So it is quicker. Usually quicker. Not always, but usually quicker. And as you can see, the best case is if the value is right in the middle. Okay, if I were looking for 5 and I check 5 first, that's the best case. The worst case scenario for binary search is, well, let's just look at an example. Let's just say we had numbers from 1 to 64 sorted. You were looking for a certain number. Let's just say we looked for the number and it was not what we were looking for. It was actually bigger than that. Well, let's just say it's all smaller. So it's smaller than that. That would get us down to 32. Okay, well, it's not 32. So next time I would cut it in half, I'd get down to 16. Next time, cut it in half, 8, 4, 2, and eventually I'd get it. So that took me, I guess, 6 guesses, because this one we just got it. Okay, 6 different checks. So it took me 6 checks to get it. So 64 is 2 to the 6th. Okay, so because every time you're halving data in, the worst case scenario is basically log base 2. If you're 64, if you're size 64, then at worst case scenario, you're going to get it in 6 tries. Okay, so that's how it works. That's the worst case scenario for binary search. Again, it's got to be sorted, usually faster than sequential search, and that's the best and worst case scenarios. So let's take a look at this list. Now we're going to talk about sorting. There are 3 sorts that you need to know. There are more than that, but there are 3 sorts that you need to know. The first one is selection sort. Now it's common to be able to show the iterations or to show what the list looks like after every pass. So what selection sort does, it takes the maximum of the list to the end of the list. But then the list that you're trying to work with gets shorter. Okay, so in other words, let's start with 7, 2, 5, 8, 1, 4, the original list. We're going to find the maximum. We check the whole list and find the maximum. It's 8. It gets swapped at the end of the list. So this has now become 7, 2, 5, 4, 1, 8. Put the maximum at the end of the list. Well, now we know 8's at the right spot. So we only check up to the one less than the length. Find the maximum of 7. 7 gets replaced with 1. So we get 1, 2, 5, 4, 7, 8. So now we know that these 2 are in the right spot. So now we only check these. The maximum is 5. So we get 1, 2, 4, and 5, swap. And now we're looking at these. And you can see at this point it's sorted, but it will still go through. Okay, 4, maximum 1, 2, and 4 is 4, swap 4 with 4. Maximum of 1 and 2 is 2, swap 2 with 2. And then 1's sorted. Okay, so that's how selection sort works. Insertion sort is the other one you need to know. There's 3. And you'll see the code for selection and insertion both. The way insertion sort works is the first pass through, the first value is going to be assumed to be in the right spot. So 7 is where it's supposed to be. But after that, every other value will insert itself. It will move to the left and insert itself in the right position. That's where it gets its name, insertion sort. So 2 will move to the left until it's in the right position. So start off 7, 2, 5, 8, 1, 4. So 2 will move down until it's in the right position. So they just swap. 2, 7, 5, 8, 1, 4. Okay, so now we're at the next index, which is now 7. Or no, we're at the third. Index 2, which is 5. 5 is going to move to the left until it is sorted. So it's less than 7. So it moves, but it's not less than 2, so it goes in between those 2. So 2, 5, 7. The rest of the list stays the same. So now with the first 3 values are sorted for themselves. So now we go to the 4th index. 8 would move down until it's in the right spot. Well, 8's bigger than 7, so it doesn't move. Then we go to 1. So I guess that would be 2, 5, 7, 8, 1, 4. In other words, it just didn't change. Then we go to 1. 1 moves down until it's in the right list. So it goes all the way to the beginning because it's less than all of these values. Okay, it inserted itself at the beginning. And then lastly, 4 moves down the list until it is in its right spot, which would be 1, 2, 4, 5, 7, 8. And now that's sorted. Okay, so that's selection sort, that's insertion sort. The last one is merge. It's called merge sort. Okay, now you're probably not going to have to do the code for merge sort, but you need to understand how it works. Okay, understand how it works, and you might have to do the merge at the end. Okay, so merge sort works like this. It basically splits the list into 2 halves. 7, 2, 5, 8, 1, 4. And basically, let's just think that it sorts these lists. It's actually a recursive method. 2, 5, 7, 1, 4, 8. Okay? These are sorted. Now, you might actually have to do the merge. So, of these 2 lists, you're merging them into one list. You basically start with this value and this value. And you say, okay, whichever one is less will go first. So 1 is less. So 1 goes in. And now 4 kind of steps up. And it's 2 It's 2 versus 4. 2 is less than 4, so 2 goes in. Now 5 steps up, so it's 4 versus 5. 4 goes in. 5 versus 8. 5 goes in. 7 versus 8. 7. And then whatever's left will just peel out. So that's 1, 2, 4, 5, 7, 8. That is merge. You probably won't have to do the recursive part of this, but you can expect to be able to do the merge part, which you have 2 lists, merging them into one list, basically checking to see which one's less, and then applying it to the final list. Okay, so those are the 2 searches and the 3 sorts.